In our experiment, dissolved oxygen was the most volatile variable in our measured results by far. After adding the fish, we saw a significant drop in dissolved oxygen due to its oxygen and cellular respiration. Dissolved oxygen also decreased when the fish was added because its waste goes through aerobic decomposition. The presence of the Elodia plant allowed excess carbon dioxide to be converted into oxygen through photosynthesis, which is why we saw the DO levels increase again. The fluctuation can be explained by the cycles of waste being produced and broken down by bacteria, which consume oxygen and release carbon dioxide through cellular respiration, and the Elodia's photosynthesis, converting the carbon dioxide produced by the fish and bacteria to oxygen. Dissolved oxygen levels can also be influenced by the water temperature, as cooler water can hold more oxygen than warmer water. But I don't think this played much of a role in the experiment, as the water temperature remained relatively constant over the course of the experiment.
Water pH is determined by a very wide range of factors, but the strongest influence was the original water source, which is the tap water from Huntington Beach, which was dechlorinated. That sets the pH anywhere from the range of 7.5 to 8, which matches with our experiment. However, due to the Elodia's strong photosynthesis that increased the dissolved oxygen while consuming carbon dioxide.
Some of our most significant observations were the visual growth of our plants as depicted in our chart, which also includes the Elodia in our measurements, as well as the growth of the plant roots to accommodate the increasing size. We were interested in the ability of the corn and moonflower roots to penetrate not only into the filter chamber, but into the water chamber. The squash and alfalfa were unable to spread their roots as far and died, and were likely outcompeted by the more aggressive plants underground in the ecocolumn. We also previously discussed the changes in pH and dissolved oxygen in the water, which were interesting to observe over time since we did not necessarily have obvious explanations for these changes, as our Elodia had not died, and some of the fluctuations occurred before the inclusion of the fish.
The terrestrial chamber had a large impact on the aquatic chamber, mainly because the roots of the moonflower and possibly of the corn grew into the chamber and drew water from it. In turn, the aquatic chamber impacted the terrestrial chamber by providing it with nutrients, both with the water taken directly from it and by adding nutrients to the soil with the usage of its water to water the plants in the terrestrial chamber. The live fish also excreted waste that was converted into usable phosphates, which according to the graph peaked over around day 8, peaked around day 9, and decreased by day 10. The live fish also excreted waste that was converted into usable phosphates, which were given to the plants through watering from the aquatic chamber. The introduction of detritivores to the terrestrial ecocolumn helped to aerate the soil and create an ease of water flow, which benefited soil productivity.
So, the questions we want to ask ourselves.
In our experiment, we wondered why the squash and alfalfa were the first to actually grow and dominate the environment, but were quickly outcompeted by the later bloomers, which were the corn and the moonflower. We also wondered how, despite getting the same soil and resources as other groups, how our crops and plants grew so much better than the other groups.
In our experiment, we wonder why the productivity of our plants became as successful as the ecocolumns of the other groups who have higher fertility levels.
Why did our nitrite and nitrate levels remain low to zero despite the presence of fish waste and Elodia to convert Elodia and nitrogen-fixing bacteria to convert ammonia into nitrogen derivatives?
And why were some detritivores more successful than others? And why did our mealworms die when they had a higher population, but our roly-polies were successful enough to reproduce despite the same limiting factors and a smaller initial population? That's our final submission for the eco columns. Thank you.